Good morning again. So today we will start with the next topic, that is the slicing in the 3D printing process. First, I will start with the what is the definition of slicing, then the different types of slicing approaches such as direct slicing, indirect slicing, uniform slicing, adaptive slicing, horizontal slicing, and conformal slicing. So I will explain each of these slicing steps, and after that we will make a comparison between all these types of slicing approaches. So what is basically a slicing process in 3D printing technology? Slicing is an essential process. See this image. Slicing is an essential process of converting the 3D model into a format that can be understood by 3D printers. This process involves slicing the 3D model into layers that are as thin as the printer can produce, with each layer typically ranging from 0.05 to 0.3 millimeters in thickness. Once the model is sliced, the software generates a set of instructions that dictate how the printer should print each layer of the model. These instructions include the toolpath for each layer, which specifies the path the printer's nozzle should follow to create the desired shape on the layer. In addition to the toolpath, the slicing software also determines other parameters such as the speed of the nozzle, the temperature of the printer's hot end, and the amount of material to be extruded. These parameters are adjusted to achieve the best possible results in terms of print quality, strength, and speed. Overall, slicing is a critical step in the 3D printing process that ensures that the final print is of high quality and meets the desired specifications. So from this figure, you can see this is my STL file. You know that what is an STL file? It consisting of infinite number of triangles. Then we will convert this STL format in a slicer. The second image represents the sliced file, means we will sliced the part into small layers, and finally the last operation will be the uploading of this sliced file into the 3D printer, and we will start the 3D printing process. Yeah, this figure little more clear. So this is the 3D model, and we will slice this layer into different layers. One here you can see 1, 2, 3, 4 layers, and finally the sliced layer. We will upload the sliced layer into the 3D printer, and this is the 3D printed nozzle. And from the nozzle, the material will extruded, and the material will fall down into the substrate, and we will get the final part. So this is the process. Yeah, let us take another example. This is the digital model. This is our CAD model, and after slicing, we will get this is the sliced file. You can see the staircase effect. See, the layer height is too high, and there is an offset on either both sides, either right side as well as the left side. There is a small offset. Because of that offset, we can see there is a staircase effect, and during the post processing stage, we will we will finish the CAD model, and we will remove the staircase effect during the post processing operations. So these are the different images related to understand the concept of slicing. So we will prepare the CAD model using any software, any either constructive solid geometry or feature based software uh, like SolidWorks, Pro-E, Fusion 360, Inventor Professional. So from that CAD model, we will convert the CAD model into STL format, and then we will slice the file, and then we will upload the file into the 3D printer so that the printer will read the sliced file, and we will start the printing process based on the sliced file we are provided to the 3D printer. So first we will prepare the CAD model, then we will convert this into, so this is actually called indirect slicing. So I will explain this in detail in the next section. So there are two types of slicing, such as direct slicing and indirect slicing. So in the case of indirect slicing, we will convert the CAD model into an intermediate format. So here the STL file conversion is a type of indirect slicing because we are converting the CAD model into an intermediate format. This is an intermediate format. So this type of slicing is called indirect slicing. We will convert the 3D CAD model into STL format, and then this STL file format is uploaded into a slicing software. Ultimaker Cura is a very good slicing software, or Idea Maker is another slicer software by Rise 3D company. So you can use any slicer software. With the help of that slicer software, we will slice the object into layer by layer, layer by layer, and then we will upload the sliced file into the 3D printer, and we will start the 3D printing process, and finally we will get the 3D printed part. So this STL file conversion is also is known as indirect slicing because we are converting the CAD model into an intermediate format. So you can use Ultimaker Cura for slice your model. Yeah. Okay. Then next is we will enter into the two types of slicing, such as direct slicing and indirect slicing. So what is the difference between direct slicing and indirect slicing? So in here you can see an image. The image on the right side, the second image, this is called direct slicing, and the first image, this represents the indirect slicing. So in the case of direct slicing, we are not converting our digital model or our CAD model into an intermediate format. So that type of slicing is called a direct slicing, whereas we will convert our digital file into STL format or any other format. Then we will slice the object. That type of slicing is called a indirect slicing. So if we are converting our CAD model into an STL file, so these types of slicing we are normally using in FDM, fused deposition modeling, because we are preparing the CAD model in dedicated CAD software, and then we will convert the CAD model into STL format, and then we will open the STL format in our Ultimaker Cura software. So that means you are converting your CAD model into an intermediate format. In the intermediate format is called a STL format. So that is what is called a indirect slicing. So direct slicing is a technique used in 3D printing where a 3D model is sliced into layers without any intermediate format conversion. This technique is beneficial for several reasons. Firstly, direct slicing eliminates the need for any additional file conversions, which saves time and reduces the chances of errors caused by file conversions. Secondly, direct slicing allows for a more accurate representation of the 3D model, as there is no loss of data during the conversion process. Because we are converting from one format to another, there will be a possibility of losing the data. So in the case of direct slicing, there is no loss of data during the conversion process. Finally, direct slicing can be faster than using an intermediate format, as the slicing process happens directly on the 3D model. Overall, direct slicing is a useful technique that can improve the efficiency and accuracy of the 3D printing process. Indirect slicing is a technique used in 3D printing to slice a part into layers. In this technique, the CAD model is first converted into an intermediate format, which is then used to slice the part. The intermediate format acts as a bridge between the CAD model and the slicing software. One example of an intermediate format used in 3D printing is the STL format. STL stands for stereolithography. We already explained this, which is a file format that represents the 3D object as a collection of triangles. When a CAD model is converted into the STL format, it is broken down into a series of triangles, which can then be used to slice the part into layers. Indirect slicing is used in 3D printing because it can simplify the slicing process and reduce the complexity of the slicing software. It also allows for easier manipulation of the part and can help to reduce errors that may occur during the slicing process. Then next we will deal with the next type of slicing process, that is called a uniform slicing and adaptive slicing process. Here again, check the image shown on the right side of the screen. The first image represents our input model, our CAD model, and the second image represents the uniform slicing, and the third image represents the adaptive slicing. So what is the difference between uniform slicing and adaptive slicing? Slicing methods are used in additive manufacturing, also known as 3D printing, to slice the three-dimensional object into a series of two-dimensional layers. There are two types of slicing methods, such as uniform slicing and adaptive slicing. Uniform slicing is a simple and fast method that involves slicing an object into layers with an equal thickness. So in the second figure, you can see the layer thickness is same for all the layers. So that's why this slicing process is called a uniform slicing. This method is commonly used in situations where speed is a priority over accuracy, or when the object is geometrically simple. Adaptive slicing, on the other hand, is a more complex method that involves slicing an object into layers with unequal thickness in different layers. This method is used when accuracy and precision are critical, or when the object has complex geometries that require more precise fabrication. Research has shown that adaptive slicing can result in parts with higher accuracy and shorter building times compared to uniform slicing. However, it is also a more resource-intensive process and can take longer to generate the necessary toolpath data. So from this figure, you can see the first image represents the uniform slicing, where the layer thickness is same, but in the case of adaptive slicing process, the layer thickness is different. Yeah, okay. Then we will enter into the next topic, that is called a horizontal slicing and a conformal slicing. So what is the difference between horizontal slicing and a conformal slicing? So horizontal slicing is a method of slicing the objects with the help of flat surfaces. So from this figure, you can see we are slicing the object with the help of flat surfaces. This technique is commonly used in 3D printing and manufacturing. In contrast, when we deal with the conformal slicing, is also known as non-planar slicing, involves the use of curved surfaces to slice the part. This technique is particularly useful for slicing complex shapes, such as organic objects, where the use of flat surfaces may lead to inaccuracies or imperfections. An example of conformal slicing is onion layers, where the layers are curved to conform to the shape of the onion. This technique is commonly used in medical imaging and other fields where precision and accuracy are critical. So I'm concluding my video. So this video is an excellent resource for understanding the topic of slicing in 3D printing. We know that the process of slicing involves the division of a 3D model into a series of 2D layers that can be printed one layer at a time. This is a critical step in the 3D printing process, as it ensures that the final printed object accurately reflects the design of the original 3D model. This video also covered a range of different slicing approaches that are commonly used in the 3D printing process. These include direct slicing, indirect slicing, uniform slicing, adaptive slicing, horizontal slicing, and conformal slicing. What is direct slicing? Direct slicing involves slicing the 3D model directly into layers, while indirect slicing involves converting the 3D model into an STL format and then slicing it. Uniform slicing involves the model into layers with equal thickness, while adaptive slicing involves varying the thickness of the layers to better reflect the geometry of the model. Horizontal slicing involves slicing the model along a horizontal plane, while conformal slicing involves slicing the model along the surface of the object. The video focused on indirect slicing, which is the most commonly used slicing approach in 3D printing. In this approach, the CAD model is first converted into an STL format, which is a widely used file format for 3D printing process. The STL file is then loaded into the slicing software, which converts the 3D model into a series of 2D layers that can be printed one layer at a time. Overall, this video provides a detailed and informative overview of slicing in 3D printing. It is an excellent resource for anyone who wants to learn more about this critical step in the 3D printing process. Thank you.